Good morning, everyone. We'll wait a little bit until more people join the webinar. Okay. Hello, good morning, good afternoon, everyone, wherever you're joining from. Welcome to today's webinar, Elevating Drone Innovation Through HP's Multi-Jet Fusion, a customer's perspective. Let's take a quick look at what we have planned for today. So we'll kick things off with a quick introduction. Then we'll hear of how drones technology is being transformed by using HP's multi-jet fusion technology. And this will be followed by a deep dive into how the technology is used at UAV Works. And finally, we'll move into a Q&A session where we'll answer all the questions that come up. And with that, I'll hand over to our speakers for the introductions.
Thank you, Lana, for the introduction. Welcome everyone to the session. Maybe let me introduce myself first. My name is Clara Quinquilla. I am the drone segment manager for HP. I'm based here in Barcelona. And as a background, I'm an industrial design engineer. And today I'm really pleased to have with me also David Ortiz, who is
Hello.
joining from UAV Works. He's the founder, but also the technical director. So, hola, David. Good to have
Hello.
you here.
Welcome.
And just to give some context to the webinar today, the idea behind this webinar was somehow replicating the talk that we had in XPONENTIAL Europe a few months ago. We also had a talk there with David in which we talk about the project that they are developing using our technology. And we felt that there was a lot of interest, and also we felt like we were lacking some time in order to deep dive. So this is the main reason why we are here today, because we were today taking the proper time to deep dive into the work that they are developing. So let's just jump into it. As Lana was sharing, you already know a little bit about what we are going to be covering today, but we also wanted to hear from you and get to know the audience a little bit better. So I believe we are going to be having a quick poll here.
Mm-hmm.
There you have it. Just to
Yes.
get to know you, to understand if you are coming from the drone industry or not, if you are facing the designing of any components, if you are looking for manufacturing. Just a few seconds for you to share.
Let's wait a little bit. As of now, we have 30 answers already. Okay. You should be seeing the results now.
Mm-hmm. Interesting. Okay, so now that we know each other a little bit more, maybe let's jump into the contents, right? So as Lana was sharing, we're going to be spending a few minutes talking about MJF and why do we have a play in the drone space in the first place, but we're going to be focusing the vast majority of the time in UAV works. So just for not taking for granted that everyone knows what we are referring to when we are talking about unmanned systems, just I want to briefly mention that we are talking about drones whenever we are talking about a device that is being managed without an onboard pilot. And as you all might thinking that, okay, we all know the aerial drones, but the reality is that there's a wider variety of drones. And yes, just wanted to make the point that our technology is being adopted in all of these four subsegments within the drones market. But due to the nature of our guest today, we're going to be focusing on aerial vehicles. So regarding aerial vehicles, the question that we get the most is why are our customer using our technology? What are they printing? So the reality in just a few words is that they are using our technology to create highly complex UAV designs to achieve the maximum performance. We're going to be seeing several examples in a minute, but when we are talking about performance in the drone space, we are talking about lightweighting parts that needs to be aerodynamically optimized. So this means that these parts are not just for rapid prototyping, but due to the isotropic strength of these parts are used as final parts. So as you can see in this slide, in which we have several examples, you can see that the adoption has been growing through different use cases, through different companies all over the world, and through different UAV models, because at the end, you can see pretty much everything from a fixed wing device to a rotatory blade, a small drone, to different cargos being printed. So just to give you an idea of the type of things that our customers are doing, first you have there coming from Unusual Machine, a company that is based in the US. They are printing this FPV drone that stands for first person view drone, which are these drones that are used inside buildings that go super fast in order to record videos. So for example, they are printing these frames with TPU, which is an elastomeric material. The idea behind is basically protect the propellers from the impacts, since again, these drones are being managed at super high speed. But then, for example, we have the Becros one. This is coming from India. This is a drone that is used for surveillance. And in this case, the printed part is the body of the drone. That's the main printed component. Also, we have the Cerveo one, which is in the second row there, which is completely printed as well. This is PA12. This drone is used for running inspections inside warehouses or difficult to reach areas. There's also the Nico one, also coming from the US. This drone was meant for rapid deployment task. And there's one of my favorites as well, which is Blue Flight, which is a drone that is meant for last mile delivery. This drone is like 1.3 meters wide, which means that this is a huge drone. And I always like to tell the story about how they ended up using MJF, because they have tried basically everything. They started manufacturing parts with carbon fiber, which is good for some components, not that good for other components. I believe that David is going to be sharing his view also on carbon fiber in a minute. But then they made the first approach to additive manufacturing by using FDM printers that at the end failed due to the surface quality of the parts. So then they iterated, they tried SLS, which appears to be too brittle for what they were looking for. Then they ended up trying SLS, which was not meeting the challenging weight requirements. And at the end, they ended up adopting MJF technology. Ever since, they have been adopting the technology for further components. So when we met them, they were printing 48 components. The counting now goes by 60 components with the same drone. So really great example on how to adopt the technology in this space. Of course, there's the hunted drone from UAV Works. I'm not going to be talking about this one because we have time later on. But yeah, I believe that this slide is useful for understanding the type of components and the usage that our technology has in this field. So I won't take so much time in order to share, but really briefly, the three main pillars of the value proposition that we have in this space. I've been talking about this for a while now. The first one, and for me the most important, is performance, because again, here we are talking about a component that are just not plug and play, but that need to be super lightweight, optimized in an aerodynamic way. So we are really good at printing parts that are really thin, but are also performing as they need to perform. So for those of you that might not be familiar with our technology, it's a powder bed fusion technology, which means that there's no need for support, which means that any kind of shape can be printed. So this is an example of the infill of a wing using different lattices patterns. Anything is possible with the technology. We just take off the powder inside the parts and we can print whatever shape. So the customization and the possibility to design anything is there. Then the second one is time to market. We're going to be seeing the story from David, but in this space, it's really important to keep on iterating on the design, optimizing the parts, redesigning the parts. So it is important in this space, the ability to print and produce fast, to test, fail, repeat, and again. And the ability to do such thing using the same material, but also the same manufacturing method is a positive thing. So this is something that we claim a lot. And also just mentioning that many of our customers do not have the technology in-house and they don't need to. Just wanted to mention that there's the possibility to print through parts providers, the different parts, which is something that I also like to mention, because there are a lot of companies populating this market. They need to grow. I mean, from the very beginning, is possible that they don't have the need to have the machine in house. That's not a problem in this space. And finally, the third column is about scalability. At the end, our technology is a technology that was born for scaling applications. So it doesn't matter how much do you use the technology, you can take this technology to the limits. So, and also just wanted to mention as well that the vast majority of the components that our customers are producing fits in our build volume, which is important. But yeah, having said the basics on the technology, let's jump into the work that David has been developing from UAV Works. Welcome, David.
Hello. Can you hear me and see my screen?
Yeah, we can hear you. We can see your screen. So maybe you can let us know a little bit more about who you are, what do you do?
Sure. Yeah, as Clara said, I'm technical director of UIB Works. We are a small company that mainly we do consultancy in engineering, and we also develop our own drone. So I want to explain you a little bit what the projects we have done in the past and what we are doing right now. And as you can see here, we have done like all kind of projects. We have done the paperwork for open a new airport, a 25-kilogram drone, mimicking the sensors of a satellite, a robot for cleaning windmills, a robot that moves in a cable. It's a cable cam. Someone will know about this kind of robots, and I will show you the electronics box of this drone later, because we did it all the boxing with multi-jet fusion. And the last robot I wanted you to show is a robot that moves inside a wind tunnel to characterize all the fluid of fluid dynamics inside of it. And and the other hand of what we do, that's what the things I showed you is the consultancy part, and this is our own designs and intended to be sell like a production product. Okay, so here we're going to talk about the Balak 360 and the Balak Patrol and the Hunter, that is the foldable multi-copter drone that is like kilograms maximum takeoff weight, and this is the electronic box of the cable cam. The Balak Patrol is a surveillance drone that weighs 5 kilograms, and the Balak 360 is a multi-role drone that can the maximum takeoff weight is 25 kilograms. Okay, as you can see, the development of that drone is like a iterative process. So we started in 2014 with this drone that is made from wood and foam and extruded aluminum. The second one is foam also, but with 3D printed parts. All in this drone was FDM, and well, I will explain you later the parts in this drone. In 2018, we switched to carbon fiber because you all know all the benefits of carbon fibers, but there were still parts in FDM, but there weren't final parts because as you can know, or you already know, um, for the pylons of the motor mounts, they don't withstand heat very well, and the finish quality is not good. So we finally switched to multi-jet fusion, and as you can see, there are a lot of parts. And in 2021, we had a final product that is still at the day is still evolving. We have some changes right now that are not in this picture, and the final product is a turbulence drone able to fly at 120 kilometers per hour, the 110 minutes flight time, 5G, camera with auto tracking, well, a lot of things. You will see a video later. Well, we adopted multi-jet fusion because it allowed us to customize every part, being able to modify everything if we need it. At the moment, we are modifying the batteries, so we need to modify this part of the outer shell of the battery. That will be super easy to do. We have no molds to modify, like super fast and cheap. And also, by iterating all the designs, we can reduce the weight a lot, as we will see with the motor mount. Okay, but first, I think I'm going to show you how this product flies and works. You are curious about that? So for the flight of the drone is totally automatic. You only have to worry about the camera, and you select to take off in the screen of the controller, and the drone will take off and circle around the takeoff point, and it will circle at the radius you set and the altitude from terrain you select. And once the drone is in the air, you only have to worry about the camera. So you select, now it is selecting the altitude, and with the second move, you are selecting the radius from the target or the takeoff point at this point.
So
Now,
David, now that you just mentioned the altitude, can you let
yeah,
us know how high does this drone fly?
you can take off and land up to 4,000 meters, but in plane mode it has the the power to weight ratio of the drone is like 2/1, you can go up like we didn't try it actually, but the numbers are like 8,000 meters. But
Amazing.
probably will be less, but as you can see, you can control the joysticks of the controller are for controlling the camera, not controlling the drone. You also can control the drone, but it's not the intended mode of operation. There's another video where you can see the tracking function. Yeah. In this blind mode, the only thing that the drone does is follow what you are looking. You can track and select where you want to look, and the drone will follow. This video, you can see the drone circles around the bow, and the drone operator, the only thing that does is make that the tracker is on the boat. Well, where some patrols in Benidorm. Moment, I'm trapped in my video. Okay, there's another video. It's pretty short. And here you can see how the tracker works on ground. In this video, the operator, the only thing that do is track the drone, track the car, and let the drone follow. As you can see, the drone can follow the car during more than 1 hour at speeds up to 120 kilometers per hour. So you can see we developed a very useful tool for police or wherever authority that needs that kind of stuff. Oh, so we ended with the video part, and now we are going to explain some of the parts of the drone. Okay. This part here is the batteries. And as you can see, there's a battery that fits from the lower part of the wing. And there's 2 built-in screws that turns one turn. And you can fix the battery in the drone and remove it only using these 2 screws. At the first, the drone was like this. The batteries were like normal battery. You place it from the center bay of the drone, but you have to remove whatever you have here, and was like super unpractical. So we decided to move to this design. We at first designed all the parts and printed FDM. The screws were popping mechanisms that you printed in another direction, in another layer direction, and then pop it out, pop it in. And we tried that it works, and then we switch to the final part in MDF, multi-jet fusion. Sorry. And this other part is the motor mount. As you can see, it's a hollow structure able to withstand the temperatures of the motor, with holes in the back to allow the airflow of the motors, and also it had a nut um, soldered in the plastic, and there's a connector here to connect it to the drone. And this evolution is more interesting because we did a lot of changes. At first, it was in FDM. We tried it; it worked more or less, but we had uh, viability issues because it, if you leave the drone at the sun, or you fly it a lot of time in hover and it overheated, the plastic will fail. So we switched to carbon fiber CNC machine sheet, and it was working properly, but it was awful in aerodynamic. So we had to put some fairlines. So we ended with a super complicated part to build and super heavy. And then we discovered multi-jet fusion, and we printed it all in one part, and we ended saving like almost 20 grams. That if you multiply that by 4, it's almost 10 grams, 100 grams. A lot for a drone that is payload is 1 kilogram.
This is wild, David. I mean, the fact that you can print just in one component by also optimizing the airflow of the part, this is amazing. I mean, this is the right usage of additive in general. So I
Yeah,
really like this storyline.
yeah, that was for us was also amazing. You can imagine being you need to assemble all this and print a lot of parts, screws, a lot of things, or it's just one piece.
Mhm.
Super easy to build, cheaper, everything lighter. So there's a picture showing the build process of the drone. As you can see, we also use a lot of 3D printed parts for the tools for mounting, pasting all the parts together. There are boxes with rocks or weight to hold the pieces on place. And okay, well, this is another project we did. In this case, there's a lot of multi-jet fusion in the landing gear, the servo covers and mount. But the most interesting part is the payload, because this is a payload made for firefighting works, where the side there's a camera, the, and this is an array of sensors that can be launched. The color of each sensor is what kind of thing it measures. One measures temperature, another one humidity and CO2, and all the box carrying the sensors um, is mechanical complex, because there's a lot of parts that allow the sensors to fall or not, and you can select the sensor you want to drop in in each place, so you can make like a perimeter around the fires. when 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 sensor triggers, you know where the fire is, or how the fire is evolving. The sensor have an antenna inside, uh, so it can communicate with the drone, and the drone makes like a relay to send the information to the ground station. The sensors are interesting because they are like a ball inside a housing, and the ball can move really inside the housing, because it has an antenna that has to be pointing upward, because the drone is upwards and needs to receive the signal. So there's a weight in one of the sides of the bowl, so the, the bowl can fall in the ground in any direction, but the sensor inside will be always with antenna up. So that's a super cool sign made for with it made it Pyro did the design of the sensors, and we integrated it in our drone. A company that works with in firefighting areas. Okay. Okay. There's another use case of jet fusion. In this case, this is a cable cam that works in outdoors, so all the electronics should be protected from rain. So we designed this box that is IP45 rated, I think. And as you can see, it's watertight. It has some seals, and well, it has the shape that perfectly matches the frame of the cable cam. Well, a, a design that is impossible to do if you are not doing 3D printing, or it's super complicated to do it. So the box only has two axes, left and right, and the doors are sealed. The actual part. There are a lot of sensors. There's a LiDAR, there's a humidity and temperature sensor, and well, a lot of antennas from data link 5G. And this is
So maybe one quick question regarding the previous case. Which IP was it?
I think it's IP45.
Which means
Which means uh, protection against solids greater than 1 millimeter and water.
like
Uh,
dust.
yeah, and water at low pressure
Mhm.
at any direction.
Okay.
Okay, we are going to talk now about the Hunter drone. Is a small drone. It weighs the maximum takeoff weight is 2 kilograms right now, and we designed everything to be 3D printed in multijet. The only thing that is not printed, obviously the motors, but there's a carbon fiber sheet inside, because we needed an extra strength for the mechanism of the folding arm. But as you can see, everything is a shell of plastic, and the shell thickness is 1.2 millimeters, and there are parts that are 0.8 millimeters. Uh, for example, the sheet, the, the 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 part above the GPS, like super thin, to have the better reception. Well, and this multi-copter, we use it to adapt it to our customers' needs, and all the lower part, it we modify it to fit with the payload that our clients need. So there's like the 3D printing all the drone make us totally free to modify the drone if our client needs something different. Well, and what's next? Next, we are going to we're going to try to the first drone I showed you, the Balak, the VTOL aircraft, to switch to 3D printed parts as much as we can, because if we can achieve a similar result that carbon fibers does, it will make super easy to build the drone. We are working also in the quality optimization for doing that, and we are trying to arrange a team to do this kind of new design. And as I already tell, this allows us to customize everything if it's needed with super easy.
Thank
Okay.
you, David, for sharing all the details on all your work. Now that in this, you have the time now to write down some questions that we can approach those in the Q&A. So maybe, David, if you can pass to the next slide. I just wanted to briefly mention that we are going to be having a booth in Exponential in Houston in May. So if any of the attendees today are planning to go, please make sure that you pass by our booth. We're going to be having as well there the drone that David just told about, which is the Hunter drone, which is a drone that I always like people to hold in their hands because it's crazy how lightweight that part is. And everyone always asks me, this must be a prototype, and their minds blow when they get to know that this is actually the final product. This is how much it weighs. So yes, I wanted to make that note there. And having said so, maybe we can just jump into the Q&A. Maybe you can also move to the next slide. Okay, so I see a few questions on the chat. Many of them are referring to materials. So they were asking David on the material that you used. I believe it's PA12. Are you using any other material?
No, not at the moment. It's
Yeah, so
PA12.
that makes a lot of sense. I mean, based on my experience in the drones space, the material that is used the most is PA12. This is probably for the great relationship that it has between the mechanical properties and also the price of the material. But it's true that depending on the component that they are printing, maybe a PA11 would be a good choice. We also have now a new material, which is a FR, flame retardant parts, that for some sort of electronic housing might make sense. Although we know that FR is not a requirement in the drones space. Some of our customers are taking advantage of this material as well in order to protect the drone. And regarding materials, just also mentioning that we also have a PA12 white version, which has really good UV properties. So for those parts that need to be under the sunlight for long hours, it's a really interesting material as well. So shall we printed the UAV entirely with MJF or just only used in certain parts? Good question. That would depend 100% on the drone. So as I was mentioning at the beginning of the webinar, when it comes to small drones, the more frequent thing to see is that they are printing the entire thing with MJF because it's really easy to approach. On the other hand, there's also customers that are printing really wide devices with MJF. So in these cases, you need to take into consideration that you need to design for assemblability, which is something that, I mean, can be implemented. So as well, we are seeing customers that are printing drones up to 2 meters, completely made with our technology. It's all about the design. And again, about the requirements of the parts. We also see some companies that are mixing some printed parts by them plus some standardized components, such as, for example, the blades. So it will depend 100% of the case. But if you need any sort of advice, reach out. We can take a closer look to your specific case. Okay, so I'm seeing more questions everywhere.
Yeah.
Wait a minute. Let's see. So for
Asking if,
example,
yeah.
mhm.
It's asking if PA is FR. I don't know what is it. It's certificate for flying device.
FR means flame retardant, and actually this is a question that is a really good question for the team that is managing flame retardant. In my head, I don't have the answer to this question. If it's certified for flying devices, I can tell you that in the drones space, it's been used. So we can double check.
Yeah. As I know, the actual the European rules for drones, you are certifying the drone. I'm talking about C1, C2, C4, C, until C6 certificates in European Union. As long I know, you are certifying the drone, and if the drone works, and that's what it's intended to do, and there's no problems during the certification, you can use any part and any material.
So there's also questions regarding the post-processing as well. Here, there's a lot of options there. For example, I believe that David, you don't post-process your parts, right?
And we are started doing some. It's like polishing with micro steel ball, something like that. That
Mhm.
improves the finishing of the part.
So maybe sharing from my experience, I have seen a lot of post-processing being applied. So for example, the drone from Becros, the one that we saw at the beginning from India, they are painting the surface of the part. But for example, there's other customers that are running a chemical smoothing, because at the end this way you can kill the porosity of the surface of the part. So it's really interesting when you need to manage the device under rainy circumstances, for example. And also a great example was Blue Flight, because you can see like this shiny finishing on the parts. Of course, that's not how it comes out of the printer. So they run this glossy paint on the top of the surface in order to have this really fancy surface, but at the same time, they are protecting the parts from sunlight and long hours under the sun. Um, Another interesting post-processing could be Cerakote coating. So for example, the one that we previously saw, which is the Nico one, you can tell that that part was green. It was not painted green, it was Cerakoted, which is a post-processing that is also interesting from a UV, UV stability standpoint. So again, there's several options. And once more, it will depend on the usage that that drone is gonna have. And once again, feel free to reach out if you need a specific advice on a specific case.
I think the Mark Rivas is a question for me.
Yeah, I mean, you can share based on your. I'm not sure whether if everyone can read the question, so maybe just in case, let me read it out loud. Hi, thanks for the presentation. It was really interesting. Regarding the design of your products, do you have freedom of design and creativity, or is everything adjusted to optimize shapes, weight, etc.?
Yeah, everything in a drone is optimized. So you need to make the shape is normally adjusted by the aerodynamics, and and also the structural strength. So it's always an iterative design where you need to improve the weight, making it the most aerodynamically possible. And yeah, so creativity, yeah, yes, you can design creatively, but uh, what the most important thing is weight and the shape for being aerodynamic.
And actually, I believe that both freedom of design and optimization are really, really related, because at the end, the most optimized part is usually that part that is that has like an strange shape that you cannot manufacture in any other way that
Yeah,
is not 3D printing the part. So I believe that is super, super related.
yeah, and yeah, manufacturing is another part that it fights with aerodynamic and structure. So if the parts can be 3D printed, there's no problems in manufacturing. If you are, for example, if you are CNC machining a carbon fiber sheet, you are super restricted in the form of the part, the shape of the part. So with 3D printed, you are free. You only have
Exactly.
to think about, in the case of multi-jet fusion, if you are creating hollow parts, you need to let all the plastic leave the part, so you have to make holes, and that's all.
And David, there's another question that applies to you. They're asking, how important is the speed of assembly to your products?
Super super important, because it's time of one person working doing the drone. So if I can avoid one person for mounting a motor mount during 3 hours, a lot of money.
Indeed.
And the drone has 4, so it's a day. So
And it's not only about the time that it takes to assemble several parts, but producing several parts and then assemble those, right? So I really like the example that you were giving to us regarding the motor mounts, because at the end, it's not only about the time that you are saving and the parts that you are consolidating in just one part, but it's also about the optimization of the entire product as a whole.
and the reliability of the product, the simpler it is, the reliability, the more reliable it is.
So let's see if we had any other question. So there's a question regarding, it would be nice to get application data regarding the oldest surface post-processing. Metallization is one part, UV, salt spray, and humidity control is also an issue. Is there a list of surface modifying process available? This is something that we have the know-hows at HP, because we have been working with different customers that are approaching different post-processing. So I mean, something that we could work on is on having a deliverable with all the answers. The easiest way to solve your questions is reaching out. Let's see what's your project and which will be our advice given our expertise and regarding the post-processing. So let's take a closer look to your specific case, because it would depend 100% on the case. And there's also someone asking about the printer that you are using, David. So I believe you are printing via a part provider, right?
Yeah, I'm not sure. Probably you know better.
Yeah, it must be a 50. Well, I'm not sure, so I will not answer. So for answering the question, David is printing by a parts provider, so he doesn't have the technology in house.
Yeah. But I think that signs are small parts. Any of the multi-jet fusion printers will do the same, or no?
Yeah. Based on my experience, the printers that are well, it will depend on the case, but 5600, 5200 solution works. Mm. So have you addressed surface printing of electronics onto the 3D printed parts?
No,
Not yet.
not yet. What we do is the wingtips of the drone are PCBs, and we use them for as antenna and as aerodynamic part, and also for landing. This part here.
Okay. So any other question? Take advantage that we have here David. If not, I believe we have answered all the questions in the chat. So thank you all for joining the presentation. Make sure that you get our emails. Feel free to reach out if you have any concern or any doubt of you want to explore anything that we have been talking about. And having said so, thank you so much for your attention. And again, thank you, David, for joining us today. It's
You're
been
welcome.
amazing to have the proper time to deep dive into the specific parts of the drone.
Pleasure.
Okay, thank you.
Bye bye.